Hello again and welcome back to the Sustain and Innovate conference. So we have two more panels for you, and our next panel talk will provide some material for discussion. The possibility of converting old cloth into new fibers is becoming a reality thanks to advances in the development of various recycling technologies. But there are still challenges that have to be mastered. So I will hand over now the moderation to the freelance journalist Sophie Bramel. Hello, Sophie.
Hello, how are you?
Hello, how are you? Fine. You too?
Yep, doing well. Happy to be here.
Thank you so much that you join us. So maybe you give a short introduction to all of who will join the discussion.
Yes, thank you. Hello and welcome to this Performance Days webinar. We will be treating the key topic of this edition, which is closing the loop. We have a great panel of speakers working for companies that are making real progress in turning textiles, in recycling textiles into textiles. And it is estimated that only 1% of all end-of-life clothing is actually recycled into a textile yarn or fiber. So what we are going to hear about today is what progress is being made and what are the different avenues that can make textile recycling possible. I will let each speaker introduce themselves and the companies they work for or founded. Cyndi, Rhoades from WornAgain, would you like to start, please?
Why not? Thanks, Sophie. It's great to be here today, and fantastic that we're going to be getting into conversation around the variation across the different technologies, because I think the industry's really reached a level of maturity where it wants to understand some of this. So well done for putting this together. My name's Cyndi Rhoades, the founder of WornAgain Technologies. We're based in the UK with a lab in Nottingham and a pilot plant up in Redcar in the north of England. And yeah, happy to be here today.
All right. Anne, can you tell us about yourself and Infinited Fiber?
Yes, my name's Anne Sarimo, and I'm the Chief Marketing Officer for Infinited Fiber Company. We're based in Espoo, Finland. We have our headquarters in Espoo and also a piloting operation here. Before I dive into what Infinited Fiber is, I'd also just like to thank you, Sophie, for the invitation to join the panel. It's a really important topic, and there's such great progress being made on this front. And I'm really honored to be sitting here today with my fellow panelists. And I just like to say congratulations to everybody for amazing work. And I think I'd like to give a special shout out to the newcell team for your recent IPO and the success there. And that really is positive progress in the industry that I think you guys should be really proud of, and it also is a signal for how this is really gaining momentum and the importance of it. Infinited Fiber Company was founded in 2016 with the mission of really making circularity in the textile industry an everyday reality, and reducing the reliance on virgin raw materials. Our ambition is to bring this to a scale large enough that we can really have some significant impact both on the industry at large and obviously, a significant impact on our planet. Our fiber technology is actually allows for textile waste to be utilized and transformed into high quality textile fibers that have properties that are sort of similar to cotton, very natural, soft, cotton-like look and feel, and also with superior characteristics, for example, high dye uptake and antimicrobial properties. Our fibers have been tested and validated with textile manufacturers around the globe. And we also have endorsement from leading brands, including Patagonia, H&M Group, Bestseller, Wrangler, and PVH Corporation. And yes, we've achieved great results from a range of applications, including denim, single, jersey, French terry, and woven shirting fabrics. And we're now accelerating to commercial scale up.
Okay. Well, we'll go into the details of that later on. Jenny Fredricsdotter, can you please tell us a little bit more about Renewcell and Circulose and yourself?
Yes. Thank you for your kind words, and we are very happy, of course, about the recent listing to Nasdaq. It was a good, very important and good step for us, of course, to be able to scale up the technology. I'm the circular business manager in Renewcell since a little bit more than 3 years, and I have a background in fashion production since more than 20 years. And Renewcell is a sustained tech company based on innovation from the Royal College of Technology here in Stockholm. Our founders are experts in cellulose chemistry, and they base their innovation on this technology. So we have a small-scale industrial plant already here in Sweden, in Kristinehamn, about 2.5 hours from Stockholm, and we have the head office in Stockholm. And now, thanks to the recent listing and the investments being made, we are now building a second plant in much bigger scale in Sundsvall, or about 2.5 hours north of Stockholm. So a different location and a much bigger plant. And we are, of course, very happy to be part of this panel.
Thank you. Juha Salmela from Spinnova, please, your turn.
Okay. Thank you. It's great to be part of this nice panel with very, very interesting and good companies. My name is Juha Salmela. I'm co-founder of Spinnova and act as CTO. I'm also behind the innovation originally. Maybe a few words about Spinnova. We are a startup company founded late 2014. Currently, we are employing some 40 people and scaling up the most sustainable textile fiber, which we can produce from wood pulp and also from very many waste streams. So circularity is really in the core of this company. And great to be here talking about this.
Very good. So thank you all for being here. Let's move on to discuss the different stages that recycling textiles into textiles requires. And the first part, obviously, is securing some raw materials. Can you tell us what type of end-of-life clothing you need? In what form does it have to come? And how do you plan to secure the right amount or the right kind of waste? Now, you probably don't like the term waste. I'm supposing you prefer resource, but let's get into the details of what is the raw material. Jenny, would you like to start?
Yes, of course. So we are working with taking cellulose-based textiles. That's mainly cotton, but we also work with man-made cellulosic fibers like viscose and lyocell. So we extract the cellulose from the textile and make it into a dissolving pulp made from the cellulose in the textile. We can work with many types of textiles, both post-consumer waste that has been collected and sorted in many different ways for different applications. We can also work with unsold goods and different type of industrial waste from textile industry. So we prefer textiles that have a high content of cellulose within the textiles. Of course, our current requirement is about 98%, but for the next coming plant, we will have a wider tolerance with around 90% cellulose in the textiles.
Okay.
So we are able to sort out synthetic mainly to some extent. And to secure the raw material, we have cooperation with several partners for the waste or the textile material. we have signed deals with several partners to secure the supply for our coming big-scale plant.
Okay, thank you.
This is both the waste trading industry and the sorters working with secondhand.
Right, okay. Cyndi, can you tell us about what kind of raw materials or raw resources your process can recycle?
Sure. So when we started our developments, we looked at it from the perspective of the problem. If you walk into an end-of-use textile sorting facility, it's everything thrown into one big pile. And we knew we wanted to develop a solution that could deal with a high proportion of the challenge. And so we knew that being able to deal with polyester and cotton was key. And so over the time of development, we have fine-tuned our what we call feedstock specification. And where it sits now is that we can take in pure polyester, polycotton blends, polycellulosic blends, and up to 10% other. So it doesn't have to be pure. We can have nylon, wool, elastane. We haven't found anything that disrupts the process. Apart from metals need to be chopped at the beginning. But we wanted to make it as flexible as possible. Now that 10% other, while it doesn't cause a problem, what it does is it creates a yield issue. So as the industry starts moving towards designing for circularity and starts designing for whether it's mono fiber recycling or dual fiber recycling, then we can start cutting out some of that, what is coming out as waste from our process. And so, we can take in any textiles that are made out of polyester and or cotton. And in terms of securing feedstock, I think Renewcell are making huge advances in terms of they have the demand or the need for that feedstock today. We're a bit further behind in terms of scaling, so we don't require high volumes. However, what we realize the extremely important aspect of feedstock and how sourcing is going to be in the future, and the need for automated sorting and improved collection systems and stuff like that. So we work very closely with the end-of-use textile supply chain to to have those discussions, to say what we're going to need in the future and how that's going to be sourced and sorted and everything like that. So I think it's an evolving space, and we all need to be. This is one of the areas I'm passionate about, and I think we need to be talking about it more in the industry because that's where the bottleneck is.
Exactly. Yeah, I agree. Yeah, that's one of the. I mean, a lot of things are complicated in recycling textiles, but that initial stock is a big issue. Anne, can you tell us about what type of feedstock your process, infinited fiber, reprocesses?
Yes, so our technology is quite robust, and we're able to take in a wide variety of cellulose-rich feedstocks from the textile waste. So today we're using 100% post-consumer textile waste, but we could also take in cardboard waste and agricultural waste streams, for example, crop residues like wheat straw or rice straw. And but our focus today has been on the post-consumer textile waste and textile waste in general, because that's where there's huge demand and it's a major problem crying out for solutions. Related to the purity of the feedstock that we take in, so we are able to take in polyester and elastane into our stream, and we've been working now with a mix of about 80% cotton-rich textile that have about 20% at maximum polyester and elastane. And much like Cyndi said, that obviously today anything removed from the process is going into a waste stream. And we want to minimize the amount of waste that comes out of our process, because everything that we do today not only is looking at circularity in terms of the use of materials, textile to textile, but we also want to make sure that we're circulating and reutilizing any of the byproducts from our system. So today we're trying to keep that to a minimum. But yeah, we're quite flexible in the feedstock, and we've had a lot of success with the 100% post-consumer textile waste. That's what's been utilized in all of the yarns and fabrics that we've produced today.
Good. Juha, please tell us about Spinnova. There's an element of textile recycling, but not only. So can you explain to us the difference?
I'm happy to do that. So we are quite different than other players in this area. We don't dissolve, for example. The starting point is that we don't dissolve, we don't do any harmful chemistry in our process. And we start our recycling ideology starts from the feedstock. We either use virgin wood, pulp, or several waste streams. These rice straw, wheat straw, barley straw, those are good examples. So our circularity starts also from the feedstock, which is in many cases waste. But for example, this shirt that I'm wearing is part of this shirt is Bergan's backpack. So this shirt used to be Bergan's backpack. So and that was a blend of Spinnova fiber and lyocell, and we have done also Spinnova and cotton blends. Those kind of products we can take back, and without any dissolving chemistry, we can recycle it with our current process. But very interesting, just lately we've been thinking and studying more and more this textile waste recycling, and it seems that we can separate fibers like polyester, whatever synthetic fiber and viscose, and return to those fibers to their own recycling routes and utilize Spinnova, viscose, lyocell, and cotton fibers in our refining method. So that makes very interesting.
Well, let's stay with you there, and then tell us about the actual process, because it is quite different. And so if you can separate out the materials, are you always grinding them out? I mean,
So our process starts from some kind of pulp. We can take just kraft pulp, what is the raw material of paper making. So we don't even need dissolving pulp. We take that into our facility, mix it with water, and mechanically refine it to microfibrillated cellulose. And that's the core of our raw material processing.
Does that mean your process is technically a mechanical recycling process?
Yes, yes, exactly. So we don't add any dissolving or enzymatic treatments if those are not needed by a customer for some reason. We can of course introduce those, but those are not in our normal processes. And then we modify the rheology so that we can extrude that through our patented spinning technology and finally evaporate the water. So, and that keeps, then we can take our own fibers back when those have been used. And again, we just refine it, chop it to pieces and refine it. And actually the quality improves with this second refining round. So we call it upscaling. So not really, so the quality doesn't go down with the recycling in our case.
Interesting. So let's stick to the cellulose methods. Jenny, can you tell us about what methods, what chemistry is being used in the circulose process? You need to unmute, yeah.
Yes, of course. So we use a technology that is very much related to creating a wood-based pulp, the method you use to transform wood into dissolving pulp, but instead we are applying this method but refined for textiles. So we have 3 steps in our plant. We have the first, the mechanical step, where we shred and cut the material. And in this step we can also mechanically remove different types of metal, for example, buttons and zippers in jeans. So we take out the metals first. Then we have a process which is the wet step. It's a chemical process. We don't use harmful chemicals, but we use the same kind of chemicals that are being used in the wood-based industry. During this step, we dissolve the cellulose, we separate the fibers, we remove the dyes, and we create what we call dissolving pulp from cellulose in the textiles. And then the last part of the production is more or less a paper plant, where we dry the material and we create sheets. So we have the pulp sheets as our final product. We are not making the fibers in-house. So our raw material is the raw material for fiber production. So from our dissolving pulp, circulose, we can make viscose fibers, lyocell fibers. Potentially, we also made viscose filament. Potentially, we can also make other man-made cellulosic fibers.
Okay. Very good. And can you tell us about the process in work at Infinited Fiber, please?
Yes, and I'm going to now share my screen here, because I think a picture is worth 1,000 words. So let's see if I can make the technology work properly here. This is always the trick when you're sharing your screen. So let's see. Okay, can we see that? So,
good.
You know, we're actually not making a pulp at Infinited Fiber. Our final product is a cellulose carbamate textile fiber. And our process starts with the shredded textiles, where all the zippers, buttons, any elements are removed when they get to us. In the picture here, the shredded textile is actually old denim. The next stage of our process is where the pre-treatment of the cellulose occurs. So any dyes are removed, any like old chemicals that existed, anything nasty in the cellulose, you could say. Polyester is removed at this stage, and if there's any elastane in the process, it's softened. Then the cellulose in the third process here, where it says cellulose carbamate powder. So at that stage, what happens is that the cellulose is activated with animal grade sort of feedstock level urea. And the urea has nitrogen in it, which bonds with the cellulose to create some of the really unique properties we have in our fiber. From the pure cellulose carbamate powder, which is where our magic happens, it's dissolved into a liquid form. So we end up with pure cellulose liquid, which then what happens is that the liquid is extruded through really small nozzles to create the fiber filaments. They're crystallized into the fiber filaments. And what we're left with is a very unique cellulose carbamate fiber with cotton-like properties.
Great, thanks. Cyndi, can you tell us more about your process, which also recycles polyester, as I understand?
Absolutely, the dual approach. I don't have so useful. If you find a washing machine, I think is the best way to imagine our process. And the chemistry behind this process was developed by our Chief Scientific Officer, Dr. Adam Walker, and he's really the brains behind the technology, and obviously our wider team in Nottingham and beyond. But to give you an overview, imagine the feedstock coming in, chopped up, buttons, metals removed. We have a number of steps. First, along the top strand would be where we deal with the polyester. So textiles go in. We're able to separate the dyes from the polyester first. We're then able to separate the polyester and the cotton. And then the polyester goes through a number of steps and filtering where it's dissolved in a solvent. The solvent, it dissolves the polyester, which then is able to separate off everything else. So anything that went into that polyester comes out, is stripped out, decontaminated, then through to almost a final step where the solvent's removed from the polyester to produce a final step that brings the polyester back up to a virgin equivalent molecular weight. Now, one key thing to say about our polyester steps is that we're dissolving the polymer. We're not breaking it down to monomers like some of the other polyester chemical recycling processes. So the benefit of that is that we're not breaking it all the way down, which means we don't have to build it all the way back up again, which takes more processing steps, higher energy and that sort of thing. So we have a finishing step that takes the polyester back up to virgin equivalent molecular weight to produce a PET resin or a pellet. And that then goes off to fiber spinners to become fiber yarn. Textiles all over again. And then on the cotton side, it goes through a similar set of steps where we strip out all the colors and everything else, dissolve the cellulose, and recapture a similar type dissolving pulp, cellulosic pulp that comes out, that then again, as with the polyester, that goes off to fiber spinners. So it's relatively straightforward. We have a closed loop solvent system. So we use two different solvents. They're recirculated as part of the process. The aim was to create a low cost process that would enable us to be able to buy that feedstock in at a good market price. And then for our future plant operators to be able to sell the outputs at a very competitive price as well. So that's it in a nutshell.
Okay. And so if I understand correctly, the two streams will lead to either recycled polyester or some form of cellulose, man-made cellulosic, whatever market is needed, whatever market you find for it. Okay, so that's fairly straightforward with regards to the outcome. I'm curious about the fibers developed by Spinnova and Infinited. So, Juha, what is the nature of the fiber that is produced, and what will it be labeled, and what are its mechanical properties?
Yeah. From the beginning, we have been targeting the mechanical properties of cotton, and we are in dry state. We are there currently. Wet strength is similar or a little bit better than viscose. So mechanical properties are there. Hand feel is between cotton and linen. So it's maybe linen is very, very close to the hand currently. And our fiber labeling is actually very interesting, and we've been doing a lot of work on that because we are super happy how EU is now, what kind of feedback we have got from there. So we want to be in the natural fiber category because our fiber is cellulose 1. So we don't regenerate that at all. And currently it seems that we can label our fiber as paper fiber. There is a category of paper fiber. So that's most probable, but still that process is ongoing. So we really want to see Spinnova fiber. Our brand name work is also ongoing, but let's say that it's called brand name may be Spinnova fiber, and washing label says that this is paper fiber. So that's one option there, and we are very happy that we are among the natural fibers.
Yeah, pretty cool. And please tell us, so this carbamate cellulose.
Cellulose carbamate fiber. So yeah, the question around what is our fiber called is always an interesting one. In terms of the fiber characteristics, it's really something quite unique. So it falls somewhere between, it doesn't really have a direct comparison, but you could say it falls somewhere between cotton and viscose. And the technical name for the fiber is actually cellulose carbamate fiber. We have a process in the EU that's undergoing right now where we have applied for a new fiber name, so a generic fiber type, much like lyocell or other man-made cellulosics. But that process is underway, and I think we'll know the results likely sometime early next year. But right now, it's technically known as cellulose carbamate fiber, and we do anticipate that could be the name ultimately that would be on a label inside a garment. In terms of the characteristics of the fiber, so from a mechanical properties, it is quite similar to viscose. However, like for example, now the blouse that I'm wearing is made with 100% infinited fiber from 100% post-consumer textile waste. And when you look at the textile, it's super soft. It's got a very matte finish, so you have these soft, like sort of the soft natural qualities. It's a joy to wear. It feels just like any other premium fabric or textile that you would buy in retail. The elasticity of the fiber versus viscose is one of the things that enables us to achieve quite a cotton-like feel, for example, and success in single jersey and French terry, basically all the fabrics. And as I mentioned before, in terms of other properties, we have extremely high dye uptake when compared to cotton and viscose. And because of the urea and the nitrogen bonding in our process, we have natural antibacterial properties. And then when it comes to one of the unique features of our fiber is the workability of it. So, and this really differentiates it from viscose, for example, and the fact that it bonds really well with cotton. So we're able to process it. It works really well in terms of the processability in existing yarn and textile mills. I think I answered the question.
Okay, interesting. And well, you didn't talk about, I guess, its characteristics when wet. Are they similar to viscose also, or? Because
you know what? To be a lot, we right now what we're seeing is that it performs quite similarly to cotton.
Okay.
And we have tests underway, obviously, because we've been working with 100% infinited fiber as well as blends up to 50% with organic cotton and polyester. Its performance depends on the different blend, as well.
Of course, yeah. Jenny, I know that you're not producing fiber, though. To be though circulose seems to be one of the most present of all the four of you. So with regards to the materials that have been marketed already by various brands. What fibers, what properties, what have you found out about its transformation into fiber?
Yes. So we are currently selling the cellulose pulp for viscose production. So we have made viscose staple fiber in fairly large volume, and these materials, these fibers are also the fibers in the cooperation launches we have had with H&M and Levi's. Yes. And we will also be part of coming launches. So it's viscose staple fibers, and they have very similar properties to the conventional wood-based viscose staple fibers. We have also tested in smaller scale to make lyocell and the viscose filament, and also these fibers perform in the similar way as the conventional wood-based fibers. So we have taken the strategic decision to make the raw material and then integrate it in the conventional production processes. This is, right. It's a commercial decision to be able to scale up and to not being forced to build our own fiber production, because we want to do big scale operations for the pulp.
Okay, well then let's stay with you. Tell us about the scaling up. What stage of development?
Yes.
What's the news there? Because there seems to be news.
Yeah, exactly. And as was mentioned in the beginning, we were very happy about the launch and making Renewcell a public company, and this enabled us to scale up the production. And we signed an agreement to build a 60,000 metric ton plant. So the capacity will be much bigger from 2022 when the plant is planned to be in operation. So this is a big scale up for us. The current plant we have is only have a very small capacity compared to that. So we hope to be able to scale up and to start to work in conventional lines. We are currently making fibers in pilot lines due to our limited capacity. So this will be a big step forward, and it will create much more possibilities for more brands to buy the fibers that we produce in cooperation with fiber producers, of course.
Right. Okay, thank you. And how close, what's the situation at Infinited Fiber with regards to scaling up and commercialization?
Yes, so we are producing fibers in our pilot operation here in Espoo. And but ultimately our business model, first and foremost, we're a technology company, and our business model is really about technology licensing, and it's targeted toward existing fiber producers, in particular viscose producers. So we've had quite an interest in, obviously, our technology does a lot of things for existing viscose producers. It's easy to retrofit into existing viscose plants. It gives them a new, really unique, premium and novel fiber type to bring to market. One of the most important things is that, as you may know, viscose uses the chemical carbon disulfide that is considered dangerous and toxic, and we remove the carbon disulfide from the viscose process, which is also one of the reasons that our fiber and our technology is really interesting for viscose producers. But that said, we've got the licensing stream, and then also because we have so much demand for our fibers from the brands, the industry is really asking us, when can we get this stuff in our hands? So an alternate track, while the licensing is one avenue, we've also, because of the appetite from the brands to start using our fibers now, we're also exploring the prospects of building our own industrial scale production to speed up the industrial transformation. And so our technology is ready for commercialization, and we expect to be sharing information on these other tracks early next year.
Great. Okay. Cyndi, can you tell us how close is WornAgain to market ready? I know it's a very different process, so there are probably different challenges compared to the viscose, the cotton cellulose clan.
Yeah, I think we picked quite a tricky one, trying to deal with both at the same time. But I think picking up on a point that Jenny was making around what our outputs are, we took a similar approach in that rather than producing a new fiber or a new product for the industry to get to know and love, we took the strategic decision to just be the reprocessor of the raw materials, so that the outputs feed back into supply chains.
Right.
And need to redesign or have to, go about textile production in any way. So I think that's an interesting point, because, what's coming out in this conversation is that we're all taking slightly different approaches. We all have different feedstock specs and outputs and end products. And that's what's really fascinating in that, we can all play a part in, the multifaceted solution to circularity. And so, where we're at in developments, we commissioned our pilot plant earlier this year. And that's really just about, carrying out multiple trials, optimizing the processing steps, optimizing the product. And all of that data then informs the next phase, which is our demo plant, which is currently in design stage. And we'll be pushing that through as quickly as we can. We that you can't rush R&D and developments. You have to do it right, and that's really our focus. But moving into the demo plant phase, that then will be our blueprint for the industrial plant, which, as Anne was saying, we're also a licensing business, and as Jenny was saying, our goal is, accelerating and expanding to really solve the problem. A niche, kind of small capacity thing. This is about the wholesale replacement of virgin raw materials. And the only way we're going to get there is, it's going to take massive expansion and massive investment by the industry. But I think once we're all to that point where, the commerciality works, the tech is proven, then I don't think investment from that stage is going to be an issue, because, it works. It's simply about expanding it, and it's a great business opportunity, and the industry needs it and wants it.
True. Yeah. Thank you. Juha, how close is the Spinnova fiber to scaling up and commercialization? What stage are you at now?
Yeah, this is a super interesting time for Spinnova. We, as many of you have seen, we have launched a pre-commercial series with some partners, and we are running currently our pilot line in 2 shifts, sometimes in 3 shifts, but mostly in 2 shifts already. So it's technology works, and we have a great partner in the raw material side. Suzano, world's largest pulp producer, has joined. Spinnova owns part of us, and within coming weeks, I hope we will be launching the first commercial factory, the location, the capacity, and all this. So really pay attention the following weeks, how we will do and where and when we will do the first factory. Then there will be another launch very soon about another waste material. So our business model is not actually licensing. We really want to be the producer, but it can be either through joint ventures or through our own production. Depends on the raw material and many things, but joint venture companies is our choice at the beginning. And then also this coming Tuesday is super interesting day for Spinnova, so please pay attention again. On next Tuesday there will be a super interesting launch, and we are so happy about these things. So we are very close to commercialization, and yeah, everything looks great in that sense. We have good partners, good owners, and good technology to really make a change in the textile industry. From the beginning, our goal has been that we really want to produce fibers in large quantities, not just some very, let's say, niche product, but our Spinnova fiber has to be scalable. Our production technology has to be scalable. We have our technology is actually a platform. We can feed very many different raw materials through the same technology, and then that's actually one way to scale our production and technology. There will be several branches, and Spinnova is the technology provider, but also the producer. So as you have said previously, in this panel we have very different kind of approaches, and ours is another different kind of approach. Yeah. And it would be actually very interesting to, even though we don't need dissolving pulp, but we definitely need to work with newcell and try out how that material could work in our process. I'm sure it goes very, very nicely there.
I'm so sorry, Sophie, but we are a little bit running out of time, and there are a lot of questions coming in, and I would love to ask some questions.
I was just going to hand you the, go ahead, your turn. I was just going to hand it over to you.
Thank you, Sophie. So there's a question for Anne. You mentioned you can work with cellulose that contains up to 20% polyester and or elastane. How do you separate these materials out, and where do they go?
Okay, that's a good question. So as mentioned in the early stage of our process, we actually have the pre-treatment where we have an alkaline, sort of a process of acid and alkaline baths that actually enable us to remove the polyester and soften the elastane in the process. Now, as I mentioned earlier, that is because we do not have a use for that waste byproduct. That is something that comes out of our process that right now we are looking for kind of places that might be able to utilize that waste stream. Everything now we recover, and either it gets put back into our process, it's utilized for energy use, or we have industrial players that can take the byproducts. But in the case of the polyester that comes out of our system right now, it's being used for energy production.
Okay. So Nia really appreciates the technical overviews, and she's asking, what are the wastes from your processes? It's a question to you all.
Well, I can start because it's super easy for us. The only side product or waste stream that comes out of our process is evaporated water. So we have no washing cycles, no dissolving bath or coagulation baths or anything like that. So we feed energy to our process, and out comes Spinnova fiber and evaporated water, which we recycle back to the refining. So it's totally unique. And when you come to our facility, you can immediately see that we don't need any protective clothes or anything like that there, because we have no waste streams and no harmful chemicals there.
Thank you. There's a question for Cyndi. Could you separate polyester and tencel viscose modal blend?
Yes, yes. The process is applicable to polycotton and polycellulosic.
Okay.
Easy answer.
Charles, want to know, it's a question to you all. Which companies provide you with the post-consumer textiles, e.g. TexAid?
We have several partners for the post-consumer waste. Our biggest supplier of post-consumer waste is Bank & Vogue, where we have a long-term contract for the new plant in quite big volumes, but we work with several others also.
Okay.
Yeah, I just wanted to say, so far we've been, the post-consumer textile waste that we've been utilizing in our process has come from collection campaigns all around Finland. So, but like Jenny and the Renewcell team, we also have partnerships. It's not just about one source, but we have partnerships that we've built. For example, we've been working with Frankenhuis and Revolve Waste in the Netherlands.
Thank you.
Yeah, and this is going to be one of those areas where because most collectors are scattered all over. There are a few key players, but there are multiple diverse collectors all around the world. It's going to require these collectors to start standardizing how they collect, how they sort, how they supply new technologies, and it won't just be one player, it will be that network, and it will be brands working with those companies, you know, as they are today with organizations like ICO, to get those textiles back into a system that can properly process them. Huge opportunities in that space. Maybe just another note about that. So we were involved in the fiber sort project in the Netherlands over a number of years, where, you know, it hugely valuable in terms of learning how the end-of-use textile supply chain works, what's in end-of-use textiles, and what the innovation is going to be that, you know, needed in the future to really make it a systemic supply as opposed to just a few suppliers. And I think this, I've said it 1,000 times, but it's an exciting area for innovation, because the amount of change that needs to happen is much more than kind of how the production supply chain will change. That's going to carry on going as it is. So it'll be interesting to see it roll out.
Thank you. So Becky quotes that lots of performance fabrics have treatments and finishes applied to them. What happens to these elements in the process? Do they add to the waste streams?
So I'll take that one. Actually, in the pre-treatment phase, yes, when you are removing the dyes and the finishes from the cellulose material, yes, that does create a waste stream. And like said, right now, it's about how to manage that waste in a safe and sustainable way. So, for example, in our process, we are utilizing the excess that comes from that part of the process is now being converted into energy production. And in the future, we're looking at how to recirculate everything back through our process. So all the waste streams will be sort of recycled within our existing process. And that's the R&D that is ongoing now.
Thank you. So Spinnova was talking about harmful chemistry. At the other companies, what kind of chemicals do you use now, and how could you replace them to become more sustainable?
If I start, we are not using any harmful chemicals. We are using conventional chemicals used in the wood industry, and they are used in a closed system, and the chemicals are, let's say, they are working in the process, but they are not coming out in the water and not coming out in the process. So we do, at the moment we consider them sustainable chemicals or sustainable chemistry.
Yeah, and I think to add to that, I think that the chemicals are, the chemicals that are going into textiles that are coming out in our processes as waste. That's what needs to be cleaned up so that we have less of the bad stuff coming in, going out of these processes. And that's something for the entire industry to be working on and improving.
Yeah, and in terms of our process as well, I have to sort of nod to what Jenny said. None of the chemicals that we're using in our process are harmful. We operate under accordance to the zero discharge of hazardous chemicals and the manufacturing restricted substance list. As I mentioned before, we are not using the carbon disulfide that is used in traditional viscose production. So that's one of the big benefits of our production, is that we are using urea, which is animal grade urea, which is sort of a natural compound. So I'd say that's one of the big advantages of what we're doing, is we are replacing in our process a very toxic chemical that exists in others.
So thank you. There's another one to Jenny. Are you afraid that established pulp producers could copy your technology?
Well, of course, we have to be careful about our IP, but we have a close cooperation with the pulp industry and the fiber producers. So, of course, there is always a risk, but we trust our partners and we have a good cooperation.
Okay.
But of course, there is always a risk.
Yeah. So David quotes that the sports industry uses mostly artificial fibers or wool. Are there any technical reasons for not talking about those fibers in innovation and in recycling?
Well, maybe I'll take that one, because wool has been recycled for ages and continues to be recycled as is. I think the big problem we have today is with the blended materials, which is an area that WornAgain is addressing. And the major fibers used today are polyester and cotton. So once we take care of those two, we will have covered 75 to 80% of everything that we wear, which is pretty good. The wool, the silks, the linens, they're great fibers. They're all part of the 1%. I wish they were more used, but the scale of the problem of used clothing that is piling up all over the place, and Jenny mentioned also the unsold garments that are probably will for in many cases could or should be recycled. So there's a lot of work to do there before we move on, for discussing every single fiber, though, And wool happens to be one of the few fibers that is recycled into second life clothing.
And maybe if I may add, just wool and other protein fibers are actually very interesting topic and for recycling, and that has not been studied very much in textile industry. We have been doing that. My background also comes a little bit from spider silk research, where this innovation started, and we've been part of that from the beginning. And Spinnova has actually very interesting things coming around protein-based fibers also, with the same technology, but again, different waste raw material there. So protein as a raw material is very interesting for Spinnova.
Okay.
Great.
So I have a last one from Eben. When designing textiles to be recycled, is it enough to use ZDHC compliant dyes and finishes, or what else can we be doing to innovate in this arena to enable less waste in your recycling processes?
Can I take that one?
What?
I think the way to do that is we need more forums for the industry to be learning about what's possible and what all of our feedstock specifications are, and being able to identify that at the design stage. ZDHC, absolutely, you know, there's a whole host of of different routes to designing for a more optimum circularity. But you know, of course, if you want, you know, clothing and textiles to be recycled or recyclable, you need to know what you're designing for. So it's these sort of platforms of engaging the brands with, I mean, I'm sure we all talk to the brand and work with brands individually, but I think it's an area where we could have more discussion, because you can't design for circularity unless you know what you're designing for. It's one and the same. You've got to connect the end technologies after you've had multiple product use phases, regenerative recycling phase. It's, you know, it's a different route and different end game.
Thank you so much. There are some more questions. Maybe we can forward them to you so you can answer this, because we are a little bit running out of time. So thank you so much to all of you. Thank you, Sophie, for joining us.
Thank you.
And moderating.